Welcome back. How are you? Okay. I think the topic out of so many, if you take op-amp and its applications, chapter number 4, sinusoidal oscillators is the one which took more time. I think it took around 7 to 8 sessions to complete along with classroom workbook problems, right? Now, the next topic, which is interesting topic, right, and definitely you can expect one question out of one of the sets in the examination, right? That is nothing but regulators. Let's start the topic and we will see. Okay, now it is again part of op-amp and its applications, but I can say this is subtopic regulators. Or power supplies. Okay, tell me, what is a regulator? Regulator is a circuit which regulates. Yes, what it regulates? I think everybody heard regulator, a gas regulator. What is gas regulator? The job of gas regulator is to do what? Whether the gas is completely filled inside the cylinder, right? Or whether you are using 2-burner stove or 4-burner stove, whatever it may be. Irrespective of load, nothing but number of stoves. Irrespective of the source or line voltage, basically the pressure in the gas cylinder. The job of the regulator is to regulate and then give you constant flame out of your burner, each and every burner. Therefore, similarly, the job of regulator circuit in our electronics is nothing but irrespective of the load variation, irrespective of the source voltage variation, people call it as line voltage variation, I am expecting output voltage to be constant. Okay. If I give you the block diagram, what is the block diagram? Then let us say, right, normally people start with a power supply, whatever 230 volt RMS you have, that is what is we can start with 230 volt RMS, 230 volt RMS, maybe 50 Hz power supply. This is 50 Hz power supply, and this is what is high voltage, this is electrical voltage. Now we need to down convert. This is what people use, step down transformer. Step down transformer. Maybe you can convert into center tapped or whatever maybe. This is what is 12 volt. I can say step down 12 volt RMS, 50 Hz, right? Then this is what. Now if you observe clearly, right, this is what is having 230 volt RMS, which is a sine wave, right? This is what is your input voltage. This is input voltage. This is input voltage Vi. This is what is having the voltage 230 volt RMS, and then peak to peak will be 230 into root 2. Therefore, that will be your that is Vm. Vm is nothing but 230 into root 2, and then it will be minus 230 into root 2. Then you will get peak to peak around 600 something. Therefore, now it will be down converted using step down transformer. Then whatever output you have here, what you get here, you will be getting down converted. The peak to peak will decrease. Okay, but it is 12 volt RMS, right? Now if this is what, now this is what is a sine wave which is down converted. Therefore our electronic components will work with it. Then it will be given to, you can say, it will be given to rectifier. Typically people use bridge rectifier. Therefore it will convert. Maybe if you ask me the output, I will draw here the output, and the rectifier output will be given to filter. This is what is our filter. Okay. Now again the filter output is going to, this is what people call it as regulator circuit, or I can say this is what is the final regulator, one more regulator. This is IC regulator. IC regulator. Okay. Now this is what is our IC regulator. Then we are going to give it to a load, real load. This is what is your real load. This is what is your DC load, or anything. But it's not only DC load, it could be anything. Therefore, this is what is the load. Right, and this is what is our output voltage, V0. This is what, right? Now if you ask me what is the output voltage here, this is what, after bridge rectifier, right? Here the voltage will be, it is something like this. This is what is, and continuously going, and this is what is your bridge rectifier output. This is bridge rectifier output. Bridge rectifier output, right? This is what is given. Once this is what is converted into kind of only sine wave, then average value, right? Whatever average value you have, here the average value is 0, now the average value will be 2 Vm by pi. That is what you will get. Therefore, the average value will be, when you say this is Vm, this is your Vm, actually this is your Vm, right? The peak maximum voltage, then your DC voltage will be 2 Vm by pi. This is what is the value, okay? That is your DC value. Okay, VDC, that is what people call it as VDC. Now this will be given to a filter. Filter is nothing but RC filter. Simply low pass filter will act as a filter here. LC filter. There are many types of filters, but if you pass it through a filter, what it does, it is trying to track. It's like envelope detector. Whatever we had studied in the case of communications, the same thing. Therefore, this is kind of envelope detector. But once it reaches peak, then the capacitor is trying to charge. We will use diode. Then the diode will be reverse bias, the capacitor will be not having any tracking, therefore the capacitor will be holding the voltage. Whenever it sees the voltage, therefore you will see the output, filter output. Therefore this is what your rectifier output. Now if you ask me the filter output, your filter output will be, therefore here the filter output, this is the input, continuously. Now filter output, right, it will be tracking to the voltage. Therefore, it is trying to charge to this voltage and try to keep it. Then little bit discharge you can expect. Again, it charges to peak, and it is trying to track to envelope. Therefore, this is what your output. When I say this is what is your output, therefore it is almost charging to peak value. Okay. That is almost charging to peak value. It is almost equal to, I can say, equivalently I can represent this as, this is what your time, okay. Now the peak values, if you see, it is almost this is what your filter output. It's like, maybe if you take continuously, it is like this. It's like, if you take the average value, if you take the filter value, it is what, a DC voltage, but on top of DC voltage there is a ripple, right? This is what people call it as ripple voltage, right? On average, on above average, this is what is average. Therefore, this is what your average voltage. On above average, this is what people call it as a ripple voltage. This is what is ripple voltage. Therefore, and this is what your average voltage. This is what is filtered voltage or average voltage. Okay, that's fine. This is average voltage, right? Then if this is what is the case, now still it is not absolutely constant. This is not absolutely constant. If this is not absolutely constant, then we want absolute constant voltage. Then this voltage will be given to, the filter output is given to, this is what is your output, right? And now this is what? Right? This is what is your bridge rectifier output. Now this is what your filter output, right? Therefore, now what is your output voltage V0? Your output voltage V0 is expected to, even though you have on top of average voltage, let us say that is what I am expecting it to be 10 volts. If I am expecting 10 volts, on top of 10 volts, I am getting what? I am getting some ripple. Therefore, that is what your ripple voltage, let us say. Then, but ultimately, if that is what is given to IC regulator, what is this IC regulator? That is what I am going to explain. Therefore, even though regulators are power supplies, it is having, this is common, remember, this is common for everything. Till filter output, this is default will be having, then the type of IC regulator what you use, that is what is going to define your output voltage. It could be Ginnar regulator, it could be series regulator, it could be shunt regulator, it could be switching regulator, kind of buck regulator, boost regulator, buck boost regulator, different things, okay? Therefore, remember, it could be anything, but this is what we are going to study, and then whatever we have in our syllabus, we are going to see. Remember, this is what is common for everything. This is what is common. This is the default, but now we are going to study about this. Now, if you observe clearly, for your IC regulator, what is your input? Our input is a DC voltage, average voltage, right? And having some ripple on it. Now, this is what? Then what is your output voltage? Now, if you ask me what is your output voltage, your output voltage will be, therefore, your V0. If you ask me the V0, this is what your time t, and this is what your V0. I am expecting output voltage to be constant. This is what is constant. Okay? How much you want? Let us say I want 10 volts. Therefore, I am expecting it to be 10 volts. Say, example. Therefore, I am expecting to be 10 volts. Therefore, the 10 volts to be constant irrespective of anything. Now, just listen. I will give you time to write down. Here, the point is, if you observe clearly, right, the input to IC regulator, is having some ripple. What is the reason to have ripple? That is because of rectifier, bridge rectifier output, and that is what is passed to filter. The filter is trying to track your envelope. When it is trying to track your envelope, that is what is having the ripple, right? That is what is having ripple. That is fundamental input or fundamental output from your filter. Even that is trying to filter out many, or it is trying to filter out so many, almost all the frequency components, but still there is a ripple which is having a frequency. It is almost equal to the input signal frequency of your filter. Now, therefore, what is the guarantee that always will have 230 volt RMS, right? What is the guarantee that you will have always 230 volt RMS? Let us say sometimes it will be 240 volt RMS, or 220 volt RMS, or 210 volt RMS, or 200 volt RMS. Therefore, let us say your input signal, this is what is varying. When your input signal peak to peak is changing, then step down transformer, the 12 volt peak to peak, 12 volt RMS, that is also changing proportional to your input signal. If this is what is changing, then the peak value Vm, that is also increasing, may be constant. Therefore, the peak value after bridge rectifier output also is changing. If this is what is changing, the DC or the filter output is also, because it is trying to track the envelope. If envelope is increasing or decreasing with respect to time, then the DC voltage, whatever I am speaking, that DC voltage is also changing. Therefore, the average voltage is also changing. On top of that average voltage, again we have ripples, right? Average voltage is also changing, and then on top of that average voltage we have ripple. Therefore, your IC regulator, the job of IC regulator is, even though the input average voltage is changing, on top of the average voltage you have ripple. It has to regulate the input line voltage, whether the DC line voltage is changing or the DC line voltage which is having a ripple. It has to regulate, and it has to give you always constant output voltage irrespective of your average voltage. Input average voltage is changing. On top of the input average voltage, even it has a ripple voltage, it has to filter out the ripples, and it has to filter out the change in the line voltage, and it has to give you constant output voltage. That is one thing. This is what is called line regulation. Then what is load regulation? Remember, practically your load is also variable. What is the guarantee that you will have constant load? Your load is also variable. What do you mean by load variation? The current whatever it draws, let us say V0 is constant. That is what I am expecting because my output voltage to be constant. That's why we can use the output from your IC regulator as a power supply. Remember, the common emitter amplifier, common base amplifier, common collector amplifier, CS amplifier, op-amp power supplies, right? We are saying VCC minus VCC. From where we are getting that VCC minus VCC? Remember, assume that those things are coming from your IC regulator output, whatever circuit. Now this is what is used as a power supply to your common emitter amplifier, common base amplifier, op-amp power supply, right? Or anything. Therefore, this is what is the load. The load will vary. If the load is varying, the amount of current whatever it takes, amount of current what it is taking, right? Then if that is what is changing, then it has to give constant output voltage. Irrespective of load variation, I am expecting output voltage to be constant. Irrespective of your line voltage change, this is what in this case, therefore, this is what is line voltage, that is what people call with respect to IC regulator. This is what is your line voltage. This is line voltage and this is what is output voltage or load voltage. Anything is fine. Therefore, your load voltage, which is your output voltage, right? Therefore, this is line voltage and this is what your load voltage. Irrespective of line voltage variation, right? Irrespective of your load variation, I am expecting output voltage, load voltage to be constant. Then only I will call this as regulator. Okay, but altogether it is a regulator, but I am going to speak about regulators. This is what people speak about, regulators, and then we have different types of regulators and those things, and out of different types of regulators, we have only one type of regulator in our syllabus. We will see what is that regulator and then how is it going to regulate your output voltage. These are all straightforward. You know what is step down transformer, right? You can get it. And you know bridge rectifier, that is what is using PN junction diode, which we studied in our engineering. Then bridge rectifier output is given to filter. Filter is nothing but RC circuit, right? Which is envelope detector. Then using envelope detector we can get envelope of your input signal. Then this is what is nothing but the DC voltage having some ripple that will be given to your regulator, and it is going to regulate even though your line voltage is varying, the average voltage is varying, and on top of the line voltage, even though your ripple, you are having ripple, your regulator has to regulate and then give you constant output voltage, and even though load is varying, expecting output voltage to be constant. Take it, I'll explain the types of IC regulators, then we will see the block diagram of IC regulator, then we will see the two circuits, then it is done, then we can solve the problems associated to IC regulator. Okay. From now onwards, if I say regulator, I am going to speak about this part. This is completely called as regulator power supply or regulator, right? But I am going to speak about this is what is the actual regulator, which is what is doing actual regulation. Okay. But these are all like kind of converting and filtering and then giving, but nothing is giving a constant output voltage. Okay, just conversions. I think you can take it, then I'll explain the types of IC regulators. Take it. I'm not going into the details of step-down transformer. I'm not going to details of bridge rectifier. I'm not going to details of filter. I'm going to give you the details of IC regulator, which is what we are having in our syllabus. I'll give you 1 more minute time. Done? Now let's see types of IC regulators. Okay. We did all these things in our lab, engineering lab. We just took it as a chip IC, then we used to connect and then we used to get output voltage. That's it. But it is defined with some input voltage range and then output load range. Okay. Done? Okay. Now types of regulators, right? One is IC regulators, but default I told you, right? Just regulators. As we go on, I'll just say that regulators. We have 2 types of regulators. Number 1, linear regulators and non-linear regulators. When you say non-linear, you can call them as switching regulators. But we don't have non-linear regulators in our syllabus. We have only linear regulators in our syllabus. Again, under linear regulators, we have 2 types. Number 1, series regulator and shunt regulator. We have series regulator and shunt regulator. Therefore, I am going to explain series regulator and shunt regulator. Why it is called series regulator? That depends on the control element. Ultimately, the control element is the one which is what is controlling your output voltage. Then, if the control element is in series to output to input, that is what is called series regulator. If the control element is in shunt to output to input, that is called shunt regulator. Therefore, I am going to explain series regulator and the shunt regulator block diagrams, and we will see the circuits, then we will solve the problems. With that, it is over. Okay. Therefore, ultimately, what is a regulator? Therefore, if you ask me with respect to block diagram, this is what your IC regulator. Okay. This is what your IC regulator. Right. Now, this is what is connected to load. This is what is our load. and this is what your output voltage V0, okay, and this is what is supplied with line voltage. This is what is line voltage, okay. Let us say Vi, input voltage to your IC regulator. Even though your line voltage is changing, it can increase, it can decrease, or your load is also increasing or decreasing, but ultimately I am expecting V0 to be constant. I am expecting V0 constant. That is what is your regulator. Therefore, even though line voltage is changing, if output is constant, this is what is said to be line regulation. It is regulating line voltage. And even though load is having some variation, but your output voltage is constant, which we need, this is what is called load regulation. Therefore, definitely your regulator should have line regulation, load regulation. Overall, it should have regulation. Therefore, ultimately your output voltage should be constant. That is what is our regulator. How are we going to get? That is what I am going to explain linear regulators, and which we have in our syllabus. I will explain series regulator and the shunt regulator. Then we will see how we are getting V0 constant. Okay. Take it. After that, I will explain the first one, series regulator, and the second one, shunt regulator. Okay. I am going to explain both the regulators using op amp. Okay. But we have some other regulator which is nothing but GNR regulator using GNR diode. GNR diode itself will act as a regulator when GNR diode is in GNR breakdown. When GNR diode is in GNR breakdown, we can get constant voltage, almost constant voltage from your GNR voltage or GNR diode. Then, but still the GNR diode will be in shunt to your output. That is also coming under shunt regulator. Okay, we will see. The shunt regulator part I will explain from chapter 5, because shunt regulator using GNR diode, okay, that is chapter 5. Chapter 5 is nothing but diode circuits. When I say diode circuits, GNR diode also will come into picture. Then I will speak about GNR regulator, but that will come under shunt regulator, because the GNR diode is the one which is what is the control element which will be in parallel to your output to input. Therefore, it is going to regulate your output voltage. But nowadays, remember, nobody is using GNR regulator. Why nobody is using GNR regulator? I will explain when I speak about chapter 5, diode circuits. And we don't have switching regulators in our syllabus. When you speak about switching regulators, right, maybe little bit, not completely. If you ask me linear regulators, for linear regulators, the efficiency, therefore the efficiency is close to 60%. What do you mean by efficiency? To regulate, to get constant output voltage irrespective of line voltage variation, load voltage variation, the power, the amount of power what you are delivering to the load, right? Then if 100% is the input power, 60% is only delivered to the load in the process of making V0 constant. Remaining 40% will be lost in the regulator. But what is the advantage? Efficiency 60%, 40% loss, right? 40% loss, power loss. But what is the advantage? You get constant output voltage, clean power supply. But in the case of non-linear regulators, efficiency, right? Your efficiency will be close to 90%. Your efficiency is close to 90%. But your output will have some ripple, or your output will have some switching output. Okay. Therefore, your output will have switching output. Switching in the sense ripple. Your output will have ripple. But here output is constant. Your output is absolutely constant, DC voltage. You will get switching output. Therefore, your output will have some ripple. Then where will you use? See, even the output is having ripple, that's fine. But average value should be constant, right? The average value will be constant, but it will have some ripple. Even if it is having ripple, that is okay. Example, we can give it to some digital circuit, right? Let us say the digital circuit ripple is not that much important. We are dealing with logic 1, logic 0. When you are dealing with logic 1, logic 0, above switching point, logic 1, below switching point, logic 0, right? Therefore, in that case, even though you have clean power supply, let us say I am expecting 5 volt. then it is not 5 volt, 5.5, 4.5, 5.5, 4.5, 5.5, 4.5. If it is having switching in between 5.5 to 4.5, still you treat it as logic 1 only, right? Therefore, example, I can give you application. Therefore, you can say people use for digital circuits. Application, digital circuits. But not all digital circuits, but you can give it for digital circuits. Low speed digital circuits. Now, if you say here example, analog circuits and high speed digital circuits. Analog circuits like your amplifiers, right? Common emitter amplifier, common base amplifier, common collector amplifier, whatever amplifiers I am speaking, therefore people are expecting to have clean power supply, therefore analog circuits are high speed, therefore digital circuits, when I say, you can say low speed. When I speak about high speed, then in high speed there is something called the clock, whatever you transfer, it should not have jitter. Jitter in the sense, the clock should not have, the rising edge should not vary. If there is a power supply ripple, it will vary, then it will make few things worse. We don't want, that's why for low speed digital circuits we can go ahead with switching regulators, because your efficiency is 90%, only 10% loss is there, right? But it will have some ripple, that is fine. On top of DC voltage having ripple, that is fine. Therefore, the DC voltage is constant. The DC voltage is constant. The DC voltage is constant. But it will have some ripple. It will have some ripple. Okay, then let's see what is series regulator. Till now only introduction to regulator. Now according to the syllabus, that is what I am going to speak now. Series regulator and shunt regulator, and how are we getting output voltage constant, that part I will explain. Over. I'll give you 20 more seconds, try to complete in 20 seconds. I'll rub it and then I'll explain what is series regulator. Okay. Now the first one, series regulator. I'll give you block diagram as well as circuit diagram. Okay. Don't write, just listen here. Why it is called series regulator? The control element, this is what is called control element. This is control element. The control element will be in series to your output and input. Therefore, let us say this is what is the load. This is the load, and let us say this is what your output voltage, V0. Okay. Now this is what your line voltage. This is what is our line voltage. Just observe. Okay. We want feedback. Remember, if you want to control anything, what do you want? I want to control your V0. Due to any reason, if V0 is trying to change, the negative feedback will come into picture and it is trying to make V0 constant. That is what. Therefore, negative feedback means we need to sample the output voltage. Therefore, we are going to sample output voltage. Then people call this as sampling network. This is what is your sampling network or beta network. Then this is nothing but your comparator or error amplifier. Comparator or error amplifier, right? And it is going to compare, the sample voltage will be compared with reference voltage. Remember, this is what your reference, it is like the reference clock what you got in the case of PLL. For the PLL, that is also having feedback, right? Your output frequency is sampled and then fed back using divider to phase detector with respect to reference clock, that is coming from crystal oscillator, because assume that the crystal oscillator output clock frequency is constant and it is stable, something like that. This is what your reference voltage. The stability of reference voltage is the stability of your output voltage. If this is absolutely constant, your output also will be absolutely constant. Okay. Now this is going to compare. If there is any change in V0, it will sample and then compare with the reference. If there is any error, that error will be given to control element. This is what is called control signal or error signal, whatever may be. Then the control element will control the current which is what is flowing through the load. Let us say the current which is what is flowing through the load is IL, and then let us say this is nothing but RL. Then your V0 is equal to IL into RL. Okay. Therefore, this is what is your line voltage. Then if there is any variation in the line voltage, if V0 is affected, then V0 is sampled, then compare with the reference, then the control signal will give the control signal to make your V0 voltage or V0 constant. Therefore, it is trying to make V0 constant. Then let me give you the circuit diagram, the same thing. This is what your block diagram, right? Now let me give you circuit diagram, then I'll explain the flow chart. Okay. Or before that, okay, let me give you the circuit diagram. What is circuit? Just listen. What is the control element? The control element is nothing but your transistor, BJT, that is the control element, and this is what is given to a load. This is what is our load, RL, okay, and this is what is our output voltage, V0. Let us say this is what is your IL, and now this is what is our line voltage. This is your line voltage. Now we need to sample the output voltage. Remember, even I am adding resistor divider, but the current which is what is flowing through resistor divider is nothing when you compare with load current. Then this is in parallel to RL. If this is very, very lesser resistance and this is very high resistance in parallel to lesser resistance, that can be ignored. This is simply sampling network R1, R2. When you solve the problems, you'll understand. Now this is what is need to be compared with a reference. Okay. Now let us say this is what is your op amp or error amplifier or a comparator. It is going to compare. It is sampled. This is what is the sample voltage, and this is what is compared with a reference voltage, right? Typically, we can get reference voltage from GNR regulator, or you can directly get from reference circuit or reference generator. Anything is fine. Earlier, people used to use GNR diode, but nowadays nobody is using GNR diode. Everybody is using some reference voltage selection, right? You can go for band gap reference, which we don't have in our syllabus. That will give you clean output voltage, but it cannot drive the load. Okay, then we need to use this circuit, this combination. What it may be, let us say this is what your reference, or we can use GNR diode, anything is fine. Therefore, if I use GNR diode, olden circuit, okay. Why people are not using GNR diode? I'll explain that later. But now if you take it, GNR diode will act as a battery when it is in breakdown, okay. This is what is some R, and this is, let us say GNR voltage is VZ, which is nothing but our reference voltage. This is what is our reference voltage, assuming that VZ is constant. And the current entering into op amp is 0, therefore the load for your GNR is not there, then it will give you almost constant output voltage under breakdown. But remember, the GNR diode should be breakdown. We have to choose R such that it will be in breakdown, therefore it will act as a battery. some problems it is given directly as a battery, assuming that I'm getting reference voltage. Okay, but the reference voltage will be coming from GNR diode. Then nowadays we want lower and lower voltage because we cannot get lower breakdown voltages from GNR diode. Like I want to get, like for example, 0.8 reference voltage. That 0.8 volt I cannot get from GNR diode. For that we have to go for some other circuit which is what is giving you a reference of 0.8 volt. Okay, that's fine. The stability of reference voltage is the stability of your output voltage. If reference voltage is absolutely stable irrespective of any condition, your output voltage will be absolutely stable. If reference is having some variation, how much is the variation? The corresponding variation you can see in the output voltage. It is like, because this is feedback concept. Therefore, for your feedback always reference is very important. If with respect to reference only we try to correct everything. If reference itself is having some variation, your output is also having some variation. That is fine. Now let me explain how it is going to correct. Due to any reason, if V0 is changing, let us say your V0 is increasing. When V0 is increasing, then this is what is called as beta V0, because you are sampling your V0, right? What is beta? R2 divided by R1 plus R2 into V0. Therefore, now tell me, if V0 is increasing, definitely beta into V0 will increase. When beta into V0 is increasing, which is plus, which is minus? We have to configure your op amp in negative feedback. We have to configure op amp in negative feedback. If you put plus minus minus plus, maybe it may change, it may enter into positive feedback. If it is entering into positive feedback, if output is increasing due to any reason, then op amp will make it increase further, then your output voltage will go to the power supply or saturation voltages. Therefore, let us say we don't know, maybe for your understanding, let me take it as minus plus. Let's analyze, then let's see whether the terminal voltages are, this is correct or not. Now let's see, when beta V0 is increasing, then voltage at plus, this is increasing. When voltage at plus is increasing, what about this voltage? The voltage at this point also will increase. When the voltage, because both are in the same phase, when the voltage at this point is increasing, voltage at base will increase. When voltage at base is increasing, VBE increases, IB increases, IC increases, IE increases, neglecting the current which is flowing through R1, R2. The same current is flowing into load. Therefore, your emitter current is nothing but your load current, neglecting this current. Therefore, if current is increasing, emitter current is increasing, your load current is increasing. When load current is increasing, drop across IL will increase, V0 will increase. Therefore, it is now in positive feedback, which we don't want. Right? I hope everyone understood. I'm just correcting it just to check. Right? You know, this is nothing but opening the loop, increase the voltage, you see other voltage, same thing. Okay? Therefore, now this is plus, this is minus. Therefore, now tell me, when this is increasing, this will decrease. Right? When this is what is decreasing, right, voltage at base, this is what is voltage at base, and this is what is, therefore this is emitter, base, collector. Whatever current which is what is flowing, right, this is nothing but your, this is your VB, voltage at base, and this is what is your IE, right, this is what is your IE, that is nothing but your IL. Let me say this is what your load current IL, right, then what is your V0? Your V0 is equal to IL into RL, right? Therefore, now tell me, if voltage at base is decreasing, when VB decreases, VBE decreases, IB decreases, whatever current which is what is flowing, right? This is what is your IB, this is your IB. When IB is decreasing, your IE will decrease. When IB is decreasing, when IB is decreasing, your IE will decrease. When IE is decreasing, your IL will decrease. When IL is decreasing, your V0 will decrease. Because when IL is decreasing, your V0 will decrease. Therefore, when V0 is decreasing, but overall, if you see, your V0 will be constant. Therefore, whether it is load variation or line variation, I don't know. But ultimately, even though RL is changing, or line voltage is changing, ultimately, I am explaining both load regulation as well as line regulation. Ultimately, your V0 is changing. When V0 is changing, let us say it is increasing. When that is increasing, beta V0 is increasing, voltage at minus is increasing, then output voltage, your control voltage is decreasing, VB is decreasing, IB is decreasing, IE is decreasing, IL is decreasing, V0 is decreasing. Due to any reason, if V0 is increasing, negative feedback is coming and then making it constant. This is what is your negative feedback, or this is what is your regulator, which is what is regulating line voltage as well as load voltage. Due to line voltage or due to load, if ultimately V0 changes, this correction will come into picture and then making V0 constant. Okay. If you compare with respect to the block diagram, control element is nothing but your BJT, comparator or error amplifier is nothing but your op amp, sampling network is nothing but R1, R2, this is the load, and reference is nothing but either GIN or diode or reference generator. Okay, take the circuit, whatever I explained here in the circuit diagram, let me explain through flow chart, therefore you will understand it. Then we have only 4 minutes for this session, you try to complete within 4 minutes, then if it is done fine, else you can pause the video and then you can take it. Okay, I will continue in the next session about the flow chart. Okay, meantime you try to draw. Therefore remember, ultimately BJT is the one which is what is controlling the current which is flowing through RL, then it is ultimately controlling your V0. That's why the BJT is called as control element. Maybe when I explain through flow chart, you will understand clearly whatever I told here through sentence format, this is increasing, the same thing I will explain through flow chart. You will understand. Okay. Therefore ultimately negative feedback. Now op amp is in negative feedback. You remember we solved one of the problems, right? What is it? Decide whether the feedback in the circuit is positive or negative, then find the voltage from the op amp output. We solved one problem, right? That is nothing but regulator. Regulator will have always negative feedback and we can find the voltage wherever you want. Okay. Okay, the session is almost done, right? We have 1.5 minutes or 1 minute time. You try to continue, then we will see in the next session I'll explain the flow chart. Okay, then we will continue for shunt regulator. Then I'll give you block diagram and I'll give you circuit diagram. I'll explain through flow chart. Then I can say both series regulator as well as shunt regulator, they are over. Then we'll see the problems. Okay, thank you.